Hello everyone and welcome. So today we'll be looking at the expert track challenge of the January Adebayo competition, Adebayo challenge, network challenge. So let's look at this. So first of all, let's start the devices. Um, so looking at this, it says the following a series of network integrations and new policy rollouts, the corporate network is suffering from slow convergence, suboptimal routing, and critical policy failures. As the lead architect, you must dive into a complex web of BGP route maps, VRFs, and redistribution policies to restore stability and enforce the correct traffic flow. So this is the topology right here, and these are some information information regarding the lab which you might want to go go through in order to make some decisions in the lab. Okay, okay, so let's console into these devices. I'd like to make this a bit like this. Okay, so just for okay, I'm going to leave it like this for now. I'm just going to bring this at the top here and leave this like this for now. Okay, so this that so remember we must answer the prompts in the document and submit that. So there is a note here, the prompts might not be in the same order to bring the network up. You might need to resolve a data prompt to make the current troubleshooting work better. For instance, the goal of maybe the entire lab might be from here, from this L call to ping, maybe the ISP, something like that. But for example, this first prompt we have here, we see that at the end of the day, we should be able to resolve something going on in this ISP, but that doesn't mean that the end goal is still possible using doing that. So something else might still make something fail. For example, let's say we might have a DHCP server here. This is just for instance. We might fix everything regarding DHCP, but our end clients, maybe our NPC might not get IP, maybe because there are still some routings that need to be done in a case where we have DHCP relay agents in place. So that's just what I'm trying to explain. You might fix the issue, but it's not taking effect because there's still something else you need to fix as you go along in the prompt. Okay, so prompt one says a new router, Adebayo ISP, has been deployed to facilitate connectivity between external partners and the Adebayo internal network. So the external partners are these ISPs. They are the external partners, and there's an internal Adebayo network here. Um, However, the required route leaking between its internal and external VRFs is failing. Diagnose and resolve this issue. So there is a big hint here that you should try to resolve this using RD and RT so that you don't maybe try to resolve maybe using routing, static route or something. So use this. So the internal network needs to be reachable at the end of the day. So let's see what's going on there. Um, so we talked about route targets and route distinguisher. So let's see what we have there. So we have external and we have internal. Okay. Can we do this more? We have external and we have internal. External with the route distinguisher of 20, colon 20, internal 10, colon 10. Let's examine what we have on this device more. We have a loopback 10, which belongs to the internal domain, and we have loopback 20, which belongs to the external. Fine, fine, let's see. And of course, E00 belongs to an external, and 001. These two links belong to external partners. That's fine. Let's see. Now we have BGP. Okay, so we are connecting to ISP1 and ISP2 using BGP. And external, we are advertising network 20. Who is that? 20.20. Okay, that's external loopback, right? Okay, that's fine. So maybe we should be doing same thing, right? In the internal, maybe where is that? Maybe in the internal we'll be advertising this too. But let's just see what's going on. Oh wait, that's the end of BGP. Why? So BGP is not even advertising the internal network we need to reach, because at the end of the day, the internal network needs to be reachable. The internal network in this case, which is 10.10.10.10, is not even advertised using BGP. So if we jump into ISP 1 and 2, we shouldn't be able to learn those. Let's see. show BGP 10.10, right? So you see, we can learn 20.20 because that's external advertised, right? But we can't learn 10.10 because it's not even advertised. So let's do the first thing. Let's advertise the 10.10 network. So let's jump into BGP. Router BGP, what's the S number? 300. Okay, now remember this 20.20 is being advertised in the external net address family. So if we want to advertise the 10.10, we have to do that where in the internal address family. So let's quickly fix that. Address family IPv4 VRF internal network 10.10.10.10, right? With a mask of 255. This is fine. This is a good solution. I saw someone else redistribute was it connected? Yeah, I think I saw someone redistribute connected. That's fine. That's fine. That will redistribute this. But the issue I have, why I don't really, I think I gave full points for that. But the issue I really don't why I really don't like that is that currently we have only one connected in the internal, right? Fine. But as time goes on, we might have more than one. We might have up to 10, 20, and we don't want to redistribute everything. We don't want to advertise everything. So you just advertising connected without a route map that is doing some filtering by specifying that okay, only take this. It's kind of in the long run, it might be an issue. It might be an issue. If I saw a route map, oh wow, I'd have been very, very happy. Well, let's go on. Let's go on. Now we've advertised this. Let's see if our guy can now reach it. What's going on? So we've advertised it and we see our ISPs cannot still reach it, cannot learn it. So there should be something else going on. So let's check. Let's check. So now we know that these are in two separate VRFs. One is in external and one is in internal. So they can learn the external because they are connected via the external VRF. So for them to learn this internal, we have to link it. We have to link the internal route to the external via some way. We can use static routing, but this example told us to use the route target and route distinguisher. So let's see how we can do that. So currently we see in the external, we have route target exporting 20. This means that it is giving out 20. It is ready to send out its the stuffs in its 20 routing table because this is distinguisher. So we need to find the way to also import the one for the internal into this external. So how can we do that? We can do that by saying route target import 10, 10.10, 10 colon 10 rather. So with that, we'll find the way to import the internal to our external. And also for this internal, we can find the way to import the external here. So let's just fix that. Um okay. So IPVRF external. So let's do our route target import 10 colon 10 now. Route targets import 10 colon 10, and let's go into the IPVRF internal um, IPVRF internal and route targets import 20. Okay, so that should be fine. That should be fine and fix that, and our ISPs should be able to learn this route after a while now. Okay, so let's just give it some time. Let's give it some time, and they'll be able to see that route. Okay, moving on to the next question. Our outbound internet traffic is not honoring the policy to prefer ISP1. Okay. Simultaneously, our inbound traffic is not being correctly influenced to prefer the same path. Investigate the BGP traffic engineering policies on NCH and resolve these two issues. Okay, so from what I understand from that prompt, we are trying to say that going outside, we want to use ISP1 as the active router, and maybe ISP2 is just sitting here waiting for the day ISP1 fails. So ISP2 is just acting as a backup in this case. So we want to influence the outbound traffic to pass through ISP1 and also influence the inbound traffic to come through ISP1. So we want to have some form of asymmetric routing. So this is what we need to do here. So two things, how we are going out, and second, how we are coming in. So those are the two things we need to do here. And as we can see here, we can now learn the 10 network here. The internal network is now being learnt. Okay, so from this ISP2, let's see if we can reach the 10.10 network. Ping 10.10, and it's not reachable. Okay, so let's reach it via the source. I think this is 9.9. Yep, show IP interface brief. Yeah, that's 9.9, and we can reach it via that because that's what it's advertising. So if we come to here right now and show BGP, or show BGP, or so we can see the internal can see 9.9. So that's why we can, that ping is successful. Okay, so that's fine. Let's attend to the prompt 1.2. So the first of all, let's fix the outbound issue. Let's fix the outbound issue. So fixing the outbound issue, how we go out, let's talk to the local preference. Let's talk to the local preference. So let's go into the edge because the issue is on this edge, right? Was it specified? Yeah, it was specified. I shouldn't have specified that. Okay, the issue is on the edge. Um, so let's see what's going on. We know that we need some form of local preference to dictate that, okay, make this one higher than this other part. So let's see if it is currently implemented, and if it is, let's see how it is implemented. Okay, we have some descriptions here. Okay, set local preference out. Hmm, let's see the local preference policy. Yeah, the local preference policy is 200. By default, it's 100, right? So now we are having a larger one, 200. But this statement here is wrong. This statement here is wrong. The direction is what changed everything. Like the direction is what makes it wrong here, because it's supposed to be in. Let's see, router BGP 65 address IPv4, right? Okay, so where is that? This is meant to be in. Um, so before then, let's check our BGP. Let's check our BGP. So now we see that even though it is applied, all the local preferences are still the default 100 because it is wrongly applied. It is not applied correctly. So let's fix that and change the direction to in. Okay, changing the direction to in, after a while we should be getting the correct stuffs, or we can just clear BGP and that should come up properly. Okay, so let's check again now, and now we can see it is now influencing. It is now influencing some parts. So now, of course, it's going to influence the parts above. All these parts below, it's not going to influence because it has no business with them. They are inside. We are trying to affect how we are going to live, how we are going to go out. So we might ask that, okay, why is it in and not out? Because we are going out. Why are you applying it in? Yeah, so it is applied in so that it can influence outbound parts. So it's just like you're applying it in and you're telling it which path should it take to leave, which path should it take to leave. So that application in is going to influence how how the traffic will go out, how the traffic is going to leave. And on the other end, AS parts, or maybe when we get there, or if we have anything relating to that in this lab. So right now, this is fixed. And if we look at this, we'll see that 1.1 has a higher preference. 1.1 has a higher preference and all of that because we did this neighbor 1.1 route local preference, and that's 1.1 is this ISP1, I believe. Show IP interface brief. Yeah, that's the ISP1 interface going to the NC edge. Okay, so that's the first issue there. The second one, investigate the BGP traffic. Second one, inbound traffic is not being correctly influenced to prefer the same path. Okay, so we need some form of AS path here. We need some form of AS path. There are other things we can use. We can use MED, but it's preferable to use AS paths because except you are explicitly told to use med. Why? Because not all ISPs will honor med. Not all ISPs will honor med. Um, for instance, we know that med is not a what's it called, mandatory attributes, right? But something like ASPAC, local preference, is a mandatory BGP attribute. So you will find it in, even though I'm creating my own version of BGP today and call it BGP version Adebayo, there are some things I must include in my BGP RFC or whatever I want to call it. Those mandatory attributes must be there. It must be there, even though I leave out some optional ones and say, okay, I don't want this, I don't want that, but there are some mandatory attributes that must be there, and that's why they are called mandatory attributes. So if we are using ASPAT, to some degree, we are sure that this is globally acceptable, no matter where you are coming from. To some degree, you will respect and you will honor ASPAT, unlike med. So that's just some, you'll get some questions. Why experts? Why not med? So this is like a good um explanation or a good response to that question. Okay, NCH. What's next? Let's check the current ESPAT implementation, if any. Okay, we have ESPAT here, and it's we have ESPAT here. Okay, that looks cool. That looks fine. Let's see how this is. ESPAT prepend 6565. Yeah, this looks fine. This looks fine. So the ESPAT is just making another part longer and unattractive. So instead of me to enter three buses to get to where I'm going, I'll just prefer to enter one bus. So that's what ASPAT does. So that's what this does. But now let's see, who is this 4.4? We want to apply this ASPAT to the neighbor ISP2, right? Because we want to make ISP2 look attractive and always follow ISP, so that it can always follow ISP1. So let's check the IP for ISP2. Okay, where do you have it here? I can't see any. I can't see any. Or am I seeing something else? Yeah, this is 4.4. I can't see any 4.4 here. So who is 4.4? Who is 4.4? Let's see. Is that UNC core 1? Show IP interface brief. Oh, yeah, this is 4.4. So the AS part is to this direction. That's considered be wrong or be a mistake. This both is either one of the two of them, but it can even be both of them. So let's fix that. Let's fix that. It shouldn't face 4.4. It should face ISP2. So let's remove this. So how do we remove this? No, right? Okay. So now let's put the proper one. What's the ISP2's IP? Um, what's well, what do we use for the pairing? I think it's E001. I think it's E001. So that should be 2.2.2.1. So let's do that. 2.2.2.1. Okay. So before that takes effect, let's just check BGP. Let's check BGP. And okay, running it again. It has taken effect here. It has taken effect here. But I'm trying to examine the first table we have here. I'm trying to examine the first table. So, for instance, to reach 3.3, the best part is via 2.2. And who is 2.2? I think, who is 2.2? I think ISP1 is 1.1, so ISP2 is 2.2. So, mm, that's going via itself, like locally, or what's that? And that's the same for every other thing here. But after using the after setting the AS path, it's now going through 11.1. 11.1, I think that should be ISP1. um, let's see, that should be ISP1's E01. Yeah, that's ISP1's E01. So all the traffic would definitely, even though the traffic comes here first, even though for some reason it hits here first, it has to divert. Maybe if there's another router connected to ISP2 and the traffic gets to ISP2, it will not come directly. It has to go through ISP1 and come inside, because that's what we want. That's what we want. This needs to be the active router coming in or going out of this network. Okay, so I think that's fine. I think that's fine. So let's check how Adebayo ISP sees this. Let's check how Adebayo ISP sees this. So um mm, 11.5, I believe um that should be ISP1, and 11.5 also, that should be ISP1. That should be ISP1. Okay, so that's fine. That's fine. So the bio ISP is also preferring to pass the ball to 11.5, which is ISP1 and not ISP2. Okay, so now prompt 1.3, a critical BGP community-based policy is failing, and route distributed from the legacy corp. Where is that? Legacy corp, that's LC, yeah. Okay, are supposed to be tagged with a specific community on NC core, on the NC cores. That's these two guys. Okay, but the community is not appearing on any other BGP router. Investigate the full path of this BGP updates from NC core 1 and resolve the two issues causing this failure. Okay, so let's see what's going on here. Okay, so we are, this is NC core 1. Let's see NC core 2. Okay, so we are seeing some community stuff here. Let's see. Um, okay, so these are the stuffs being tagged. So set prefix list right here to match, to set the community. So set the community matching legacy corp. And this is the IP for legacy corp. Another one to set community matching startup. I believe that should be similar on this other end also. Yes, that's similar. That's similar. So let's see the community things again. So now we are saying neighbor 5.5 send community. Send community. Okay, that's fine. So who is this neighbor 5.5? Mm, I believe it should be this guy. Show IP interface brief. Okay, this is 5.5 and C1 is 4.4. So from what we can see here, they are sending the community, like they are sharing this information with both of them. They are sharing it with themselves. They're sharing it with themselves. Um, they're sharing it with themselves. Fine. So how about this guy here? How about this guy here? So they are not the only routers that need to know about this community. They are not the only routers that need to have this tag, that need to have that tag. So going to this edge right here, which is in the same AS with them, they need to send that community to that also while advertising stuff to that edge. So that needs to be included here. That needs to be included. So on currently on core 1, it is sending correctly to 5.5 neighbor, but it is not sending to 3.3 neighbor, and we need to fix that. Core 2 is sending correctly to 4.4 neighbor, but it is not sending to 3.3 neighbor, and we need to fix that. So let's do that. Config C router BGP 65000 address IPv4, right? So neighbor 3.3 send community. Okay, then the same thing here. Router BGP 65 address family IPv4 neighbor 3.3 send community. Okay, that's fine. That's fine. Now there's something else. There's something else. Um One is related to route the reflector configuration, and there's another issue which some other configuration, which is what we saw now and fixed. So these two devices are operating as route reflectors, and they are like in the same cluster. They're in the same cluster. So for them to be in the same cluster, there is something unique that they need to have. They need to have the same cluster ID, because that's how route reflection works. That's how route reflection works. And that is what it uses to stop loops from happening. It uses cluster ID and originator ID. Cluster ID and originator ID. So these two guys need to be on the same cluster. So we need to check that. They need to have the same cluster ID rather. Okay, this is fine. So this has 4.4 as its cluster ID, and this has 5.5. This means that they are not on the same cluster. They are not on the same cluster, and we can have issues on this network. So for them to operate as an integrated body, as an integrated cluster, one cluster, they need to have the same cluster. So let's just change one of the clusters, one of the cluster IDs rather. Let's just make it match the other end, and everything should be fine now. Everything should be fine for this prompt. Okay, going into the next one, we have routes from the newly acquired startup X are not being learned correctly in the OSPF domain. Okay, well, before this, let's see if we can do something. This is the distribution router. Let's just see. Oh, we're having some issues. Duplicate router ID. What's this? Maybe we'll get there. Let's check the routing table here. Okay, so it looks to me like this guy is learning up to this 10.10. So this is fine. With what we've done so far, this distribution router here can reach the internal Adebayo network. So from here to here, it's quite fine at the moment for us, so we think. Okay, let's continue. So prompt 2.1, routes from the newly acquired startup X. Oh, this is the newly acquired company. Okay, it's a RIP domain. Oh wow, they are not being learned correctly in the OSPF core. Investigate the distribution issue. So if we read the documents we have here, we'll know that our OSPF core. Let me see if it is stated here. So BGP is stated, EIGRP is stated, the legacy copy is the EIGRP. Okay, OSPF is not stated here, but the OSPF core is this guy, is here, right here, is here. We are also running some OSPF right here. Integration router, I think, is also running some OSPF. So what we are trying to say here is that, or what's going on here is that this guy, NC distribution, is not learning stuffs from this guy startup. So let's see what this guy has in the first place. Show IP interface brief 192.168.3.1. Okay, let's see. Show IP routes. Okay, we already have IP routes here. So we cannot learn that 192.168.3.1, and we need to learn it. So there is something going on which we need to fix. So let's see. Let's do that. Or let's try to do that. Okay. So on this startup X RIP, let's see if it is running RIP at all. Maybe if it is configured. Uh, okay. So this is it. RIP. That network is being advertised. Who is this 10.0? I believe that should be the interconnection. Okay. Okay. So I think the RIP for this end is fine. It's connecting to integration router. So this should be running some form of RIP also. And let's just ignore these errors for now. We'll see if we have to fix that. If we are not asked to fix it, then maybe we'll just find the solution later. Show run and see if we have some RIP here. It also has RIP. So there should be how do we check RIP? Is it RIP neighbor? Uh, show. Hmm, yep. Show IP RIP neighbors. We are not seeing anything. Why are we not seeing anything? Integration router E02. Okay. From the integration router, let's see, can we learn the 192.168.3.1? Okay, we can learn this network from the integration router. We can reach that net, we can reach the loop back of the startup. We can reach the loop back from the integration router. So we know that integration, we are fine from this point to this point. So the issue now is that this integration router is probably not advertising it to this guy, or maybe he's doing it, but he's not doing it well. Let's see what's going on. So integration router, let's see what you are doing again. Are you, we know that integration router is running OSPF with this guy. Yeah, yep. He's running OSPF with this guy. Show IP OSPF neighbor. And why? Okay. Um. Well, if it's not showing, then maybe something is wrong. This is the distribution switch. Show IP OSPF neighbor. So it's showing its OSPF for these two guys, but it's not showing its OSPF for these guys. Maybe something is wrong with the OSPF. Well, maybe. Let's see if we can um let's see how this guy is advertising the routes into OSPF first. Well, I think we should even bring up OSPF before looking at how it is advertising the routes into OSPF. Yeah. So, but we can say our OSPF is getting an issue here. Duplicate router ID detected from 10061 on E01. So what's that? That's from this link. So let's check the router ID on these two guys, integration router and the NC distribution guy. So let's see. Show run. What do we have on our router ID? Yes, 6.6, right? Now let's check the integration router. Show run. Also 6.6. That's the issue. That's the issue. So is there any documentation for the router ID here? Mm, 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 mm. Loopbacks are used as the router ID. So let's check show IP interface brief 7.7. And this one is what? Show IP interface brief 6.6. So this one is correct, but this one is wrong. So in the solutions, I saw some people just change the router ID to something, maybe 10.10 or something. But yeah, that's fixed the issue, but it's not really a good solution because we don't even know if that 10 dot something is used somewhere else on this network, or it is not intended to be used here, or it has been reserved to be used elsewhere on this network. So that's why it's cool to check what the documentation says first. So let's change this router ID here. Config T um router OSPF. What's the number? 1. Router ID 7. Okay, so let's okay. So we see the OSPF is up now. Do show IP OSPF neighbor. This is fine right now. So maybe this was even the issue why we are not learning this stuff from the startup. Because if the OSPF is down between these two guys, of course we can't learn this startup. So let's check here again if we can learn that 192.168 route. Um, show IP routes. Okay, so right now we can learn this route. Let's see, ping 192.168.3.1, and that is fine. That is fine. Okay. Um. So let's see. Now let's note something here. So now we fix this issue. We fix this issue. But this is not what the prompt is really asking from us, because now how did we fix it? We fixed the router ID stuff, right? Beautiful. But this prompt is talking about that there's a redistribution issue going on here. So like route import issue. So where is the integration point, the import point in this network? He's on this guy. So let's see what this guy is doing. Show run, and let's see how it is maybe important. Let's see. Currently, we are talking about OSPF and RIP, right? We're talking about OSPF and RIP. So now in this OSPF, it is just redistributing RIP subnets. Mm, let's examine what we have there. Okay, going further, right here, we see we have some route maps. And what are these route maps really doing? The first one here, OSPF out filter tags, match tag 90 and 120. We have another one, route map RIP in set tag 120, and another one here, set tag 90. Okay, I think what we are looking at here, what we are looking at here would be applied more on this from 2.2. But now, since we are talking about OSPF and RIP domain, because that's what this is talking about, RIP and OSPF. Let's just see what relates RIP and OSPF right here. So here we see that we have a route map called RIP in set tag, RIP in set tag here, and on our OSPF here, in our OSPF here, where is it? On our OSPF here, we don't have anything. We don't have anything bound to this RIP in set tag. So right now, let's just set that tag. And when we are working on this prompt here, I think it also covers that. I'm going to explain more on what's going on there. Okay, so router one, I think this is the name. RIP in set tag. Okay, router OSPF one. I believe that's it. Yep. Redistributes RIP route map this. Okay, that's fine now. Those should all what we are doing here, we are trying to avoid loops. I'm going to explain better in prompt 2.2. In prompt 2.2. Okay, so we've set that tag now. We've set that tag now. Let's confirm this guy can still reach this. Okay, it can still reach that. Um, okay, so let's explain what's going on there. Okay, so I think yeah, we need to go back to the integration point. This is the guy bringing in all these issues, all these two-way um distribution stuffs. So now let's see what's going on. We have three autonomous systems here. We have EIGRP, we have OSPF, and we have RIP. Beautiful. Now in our EIGRP, we are importing OSPF. Oh, very cool concept. In our RIP, we are importing OSPF. Another beautiful stuff. Now in our OSPF, we are importing both EIGRP and RIP. We are importing both EIGRP and RIP. Um, what's this? Why is it this small? Okay, I need to expand. Oh wow. Okay. Um, so this is our OSPF. This is our OSPF. This is our RIP. And this is our EIGRP. So we have our connections. We have our connections. So from our OSPF, we are importing RIP. So RIP can enter OSPF. From our OSPF, we are importing EIGRP. So it can enter OSPF. The routes from EIGRP can be known in OSPF. On the same end, we are from our on our EIGRP, we are introducing OSPF also, and on our RIP, we are also introducing OSPF, and this will introduce loops. This will introduce routing loop into the network. It will introduce loop into the network because a route length via let's say a route that should be length via RIP now can now we'll see that route just going about because it is not just right in real right here. We are now importing and all of that. So now we provide there's a solution right there on that lab. There's a solution right there. So maybe not a full solution because of course we have to do some stuffs. Okay, so all these route maps we have here. So we see if route map EIGRP in set tag to 90, route map RIP in set tag to 120. What this means is that if we are importing EIGRP into OSPF, set the tag to 90. I believe that's what it is, right? Yep. So this is it right here. So any route that is being imported from EIGRP into OSPF, tag it as what? 90. Anything we are importing from RIP into OSPF, tag it as 120. Okay, so right here, anything entering here is going to have 120 tag, and anything entering here is going to have some form of 90 tag. So what OSPF should now do is that, oh, okay, these guys are very smart. So EIGRP is tagging all the routes it's sending to me so that when this route comes into me, I will know that this is coming from EIGRP. So I don't need to send it back to EIGRP. So OSPF needs to know that anything I'm redistributing, anything I'm importing back into EIGRP should be without the ones with the tag 90. And the same thing for RIP. Why am I calling it I something? For RIP, OSPF needs to intelligently know that okay, this guy is so smart. So it's tagging all these things with 120 because it's telling me that anything, or it wants me to know that oh yeah, I'm tagging them as 120. So if you want to send it back to me, only send the ones without the tag 120. So now OSPF must find a way to deny any route with these two tags from entering these two domains. And I think we almost have a solution. So we see OSPF also has its own OSPF out filter tags, and it is matching 90 and 20, right? Beautiful. Let's see where that is going into. So you can see when it is when it is importing anything into RIP, it sets that tag. So RIP checks, is there anything like 120 tag in this? And EIGRP also checks, is there anything like 90 tag? So OSPF has also intelligently done its part, but there is an issue. It is permitting anything with these tags. So it means that anything with these tags are still going to enter these domains. And of course, we don't want that. We want anything with those tags not to enter. So the correct solution here should be deny. It should be deny. So I just had to quickly explain that about the distribution and the logic and the solution sets for what we are doing here, so that we can really maybe understand what is going on there. Okay, so let's try to remove this. So let's remove that. Okay, I hope that's fine. So now let's do that again. This time deny and set tags to what? Is it set tags? Match tags 90 and 20. 90 and 120 rather. Yep. Yep. These ones are setting the tag while this one is trying to match to check for the tag. So let's see if what we did is fine. Okay, so now this is cool. This is cool now. So at this point, this is where we are going to appreciate what we did for what was that OSPF here, whereby we set the tags. We needed to set the tag using this policy so that we'll be able to control what is coming out and what is going in. So that is that. So with this, we've been able to cover prompt 1 and prompt 2. Prompt 2.1 and prompt 2.2 rather. Okay, so that's fine. Okay, the final part here, the OSPF adjacency between core 1 and core 2 is down. Oh, really? Investigate and resolve the issue. Wow. Why is it down there? Show IP OSPF neighbor. Is it down? Who is 6.6? Is it not core 2? Let's check. Do show IP interface brief. Okay, this is 5.5, not 6.6. This is 5.5. So why is it having pairing with 6.6? Who is 6.6? Is it this guy? Okay. That's the IGP. This should be 6.6. Oh no, this is not 6.6. This is not 6.6. Oh yeah. This is 6.6, the distribution. Let's see. Show IP interface brief. What if we check and it's something like 16.16? Okay, it's 6.6. Okay, that's fine. So NC core 1 is having with 6.6 and 3.3. Who is 3.3? We just checked is this guy up here for the IGP, of course, but it's not having with this guy. So what's the issue? What's the issue? We can try to investigate configuration, but there's something I did in the last we did in the last video. I think that was for the foundation video. think we try to debug IP OSPF. This is a neighbor issue, right? Adjacency. So let's take that adjacency. So the debugging is on, and we'll try and see if mm, mismatched authentication key ID1. Really? So, okay, let's check that. So show run. Let's check what it's complaining about. Why do we have all these commands like this? Abi? Is it okay? So it has given us mismatch. So let's stop that so it can stop all these messages. Okay. OSPF. Why am I checking BGP? God. OSPF, right? So let's check the interface. E0. Okay. Message digest key one expert. Let's see what's going on here. Do show run. Oh wow, wow, wow. So we can see this is expert and this is expert with exclamation mark. Let's see if the correct password is documented. I don't think that is documented. So we just, in this case, we just need to modify the password. That should have been documented, by the way. So just modify the password in a way that will match. So let's just try to change this here to expert. IP OSPF message digest. Would it allow me to do this like this? Experts. Yeah, it's not going to allow me. Okay, so let's try that again. Okay, and that adjacency should be up in a bit. Okay, so that's fine. It's up now. Show IP OSPF neighbor, right? Yep, that's that. Um, so this is that. This is fixed. Now 3.2 network monitoring is reporting continuous OSPF LSA flooding originating from the integration router. Oh, wow. But we don't even have any network monitoring tool here, so why are they telling us this? Okay, and this is causing network instability. Furthermore, some traffic is being black. So two things now. This is the first thing, and this is the second thing. Some traffic is being black code from the OSPF domain. Wow, what's black code? Okay, identify and resolve the two issues: the critical OSPF faults related to router identity. I think we saw something like that before, when we saw the router ID. So I think we already fixed that issue. We already fixed that issue right here, and we changed the router ID to 7.7, and the OSPF was up. So we've already fixed issue one. And the second issue here, summarization. Summarization. So what's happening here? Let's see. Okay, some traffic is being blackballed from the OSPF domain. Identify and resolve that. Identify and resolve that. So let's see what's going on there. This is our OSPF guy, she. Yep, that's our OSPF guy. Let's see. Um, any no. Mm, 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 mm. Black hole traffic or summarization. Okay, so let's look for summarization in our OSPF first and see. I can't find anything here. How about here? Can't find anything. What's this distribute list? Well, let's leave that. I can't find anything relating to summarization here or any black hole. Okay, so so that's one of two things. Maybe that was just there to make us troubleshoot for a while and looking was not lost, or which the second reason is I think that's the main reason I forgot to add default. I forgot to add default. So I think I forgot to add this summarization. I had it in my head, wrote it here, but actually forgot to add defaults in the lab. Okay, so sorry about that. Sorry about that. So maybe in future labs we have more issues like that, maybe summarization or something related. Okay, so verification, provide the output of a successful ping from the startup routers to back to the, okay, so let's see if this guy can he even learn. Let's see if it has routes. Show IP routes. Oh, It's learning it too. Okay. This is our type of network that we are not using default routes. We are just learning every route granularly. Well, let's see. That's the requirement, so that's fine. So ping 10.10.10.10 source 192.168.3.1. That's fine. It can reach it. Show the output of a show IPBGP2 from the NC edge. Okay. Show IPBG. I don't want to type this. I want to use my tab. So I want it to auto complete for me. So I need to come here. Advertised routes. Okay, so with this, from these screenshots, you can verify the local preference if it was properly modified, even without looking at the configure, even without looking at the steps and stuff like that. Okay, so I think that's the end of this solution video for this dab. Thank you so much for watching to this point. Now we're going to see in the next challenge, the February challenge, which is going to come up sometime around yeah, we're going to come up second Saturday. That's 14th February. So that's fine. Thanks so much, everyone. See you next time, and bye.